Okay, so let's talk about hydrochloric acid synthesis. How do we get hydrochloric acid in our belly, in our stomach? Okay. Well, let's look at the cells here. So we've got a blood supply. We need that. So here's our little blood vessel. And running next to it are our little cells. So we've got, let's just put a cell here. And let's put this one here. So this is the cell we need. So hydrochloric acid synthesis occurs in parietal cells. So in the stomach lining we've got chief cells, and we have these parietal cells. All right, and in our little picture here, this out here is the lumen of the stomach. Okay, and here's our little blood vessel. There. Okay, so one thing you want to be reminded of, again, is this guy. So the CO2 plus water gives carbonic acid, which is broken down to hydrogens plus bicarbonate. So we've seen this one before, okay? All right, so in the blood, you have CO2. And the CO2 comes into the parietal cell. And when it does, the parietal cell will take that CO2 and add water. And we will get carbonic acid. Carbonic acid can be divided into two things. So bicarbonate, and hydrogen. Okay? So the hydrogen is what's needed to make hydrochloric acid. You need hydrogen and you need chloride. Okay? So chloride will come from from outside of the cell, from the extracellular fluid. So we have chloride that comes in to the cell, but because it's a negative ion, it can't just come in. So it's pumped in through a carrier, a little transporter. So chloride comes in and bicarbonate goes out. And it goes into the blood. Okay? So it does this so that the chloride can come and be shuttled out. So here comes chloride, and I guess it's the wrong color, into the lumen here. The bicarbonate in turn goes into the blood. And as it continues to go in there, bicarbonate is alkaline. So it's raising the pH of the blood right here. So we call this thing, let me use my other color. We call it the alkaline tide, because it is raising the pH as the bicarbonate comes into the blood in this area. Okay, so we've got that going on. We've got chloride going into the lumen of the stomach. So the hydrogen, we need the hydrogen, so the hydrogen needs to come out as well. So there's a carrier then, or a transporter for the hydrogen. So hydrogen is here, and it's a positive ion, so we need a positive ion to come into the cell so this one can go out. So hydrogen goes out, and potassium comes in. Okay, so it's a pump, because there's more potassium in the cell than outside of the cell, because that's the way all cells are. So potassium's being pumped in, hydrogen is being pumped out, 1 for 1. But we know that potassium, because there's lots of leaky channels for potassium, is really going to go right back out into the lumen of the stomach again, just by virtue of that. That's what potassium does. So once we have the hydrogen in the lumen and the chloride in the lumen, what happens? Well, they come together and form hydrochloric acid in the stomach. And that's how we get hydrochloric acid in our stomach, which is extremely important for breaking down nutrients and for killing bugs and bacteria and things like that. So stomach acid is a very good thing. Okay, so I think that's it for that. All right.